Okay, so good day. So we will have our 8 and 9 example respectively. Okay, so we will solve this 2.22. This is its figure, and then 2.24. This is the figure. Okay, so I'm still under chapter 2, basic operations with force systems. Okay, so here we will compute the moment. Okay, so both questions is computing the moment. Okay, so please be reminded that the moment is equivalent to the force multiplied by its um, perpendicular distance to a certain point. For example, m of A is equivalent to a certain to the force multiplied by its perpendicular distance to the A. Okay, so whatever its form. Okay, so just like the forces, um, the easiest way to do, in my own opinion, is to break down the forces into components, and then apply the basic operation in which that component of the force will be multiplied by the perpendicular distance relative to the point we are referring to. Okay, so for example, 2.22, determine the magnitude and sense of the moment of the 800 Newton force about A. So here, you can see this figure. We have an 800 Newton force, which is neither horizontal nor vertical. So therefore, we will convert this into components, the x and y components. And then this x, if you are referring to x-axis, so you will use the vertical. Okay, a-axis is horizontal, so its perpendicular distance is vertical. So if we are referring to the force which is vertical, its perpendicular distance is obviously horizontal. Okay? So, so without further ado, we will see immediately the solution. Okay, so this is the solution point for 2.22. Okay, so I just copied the question and then the figure. Okay, so here, as you can see, 800 has, I break it down to components, which is the x component is obviously, okay, so we can break down this to 800 cosine 38 for x component and 800 sine 38 degrees for y component. So this is its components. Okay, so from that we can use that in our solution. So m of A, our moment about an A, is equivalent to 800 cosine 38 degrees, that x component here. So 800 cosine 38 degrees, we multiplied it by the perpendicular distance. When we say perpendicular, it's like this. So if this is your x-axis, y-axis, the perpendicular distance is here. So if it's horizontal, then the perpendicular distance is this ball pen. So that is perpendicular. So same as this. So 800 cosine 38 degrees is horizontal. So its perpendicular distance is 0.6 meters. And its y component, 800 sine 38, it's vertical. So its perpendicular distance from A, okay, relative to 8 is 0.5. 0.5 is x or horizontal. So therefore, okay, so MA is 800 cosine 38 times 0.6, okay? So I make it as positive. So as we can see here, it's positive. So we assume that the the clockwise is positive. So okay, assuming positive si clockwise, so 800 cosine 38 times 0.6, then minus, okay, so why minus? Since 800 sine 38 or the y component will tend to rotate at a counterclockwise. So negative. So, minus 800 sine 38 degrees multiplied by perpendicular distance 0.5. So, we get 131.981 Newton meter. So, this is for 2.22. Okay. So, we back. Okay. So, we'll back at answering 2.24. So, this is the figure and this is the question. So, okay. So, let's make it larger. Okay. So, the two forces can be replaced by an equivalent force R acting at point B on the beam. So, determine the distance B that locates B. Okay. So, the question here is equivalent R acting at point B. Okay. So, we will replace these two forces P with a vertical force R located at point B. Okay, so here it is a double, we are asking for the R and then we are asking for the B. Okay, so we can, in this problem, we will use the properties of moment. Okay, so moment, as I have previously said, moment is equivalent to the force multiplied by the perpendicular distance. So that is the moment. So here, I just copied the problem and then the figure. Okay. So this is the solution. Okay. So first, before we go, I converted one of the forces, which is P here, into components, the X and Y components. But first, I tried to compute. Okay, so I tried to compute the theta. So since the y-axis is 3.5 and then the x-axis is 2.5, so if we assume that this angle between the P and the horizontal is theta, so therefore tangent theta is y over x, which is 3.5 over 2.5. So theta is 54.462 degrees. Okay, so since B is in between, so in order that to maintain an equilibrium, so since we are talking about dr, so therefore this P, okay, this vertical P relative to B, its moment will counteract the P on the right side. Okay, the P on this left side, the moment of P on this left side and the moment of P at the right side should negate each other. So therefore, it will be they should be equal but opposite in direction or equivalent to 0. So therefore, P, okay, so we are looking upon the left, P times 2.5 minus B. Okay, so this is the distance 2.5 minus B, so its moment arm is equal to P sine 54.462 times B. Okay, so why P sine? Since we are talking about the vertical component of P. So the horizontal component of P has no moment arm, or the moment arm is 0 because it's parallel to the body. So its component of x-axis is 0. I mean the moment arm of along the x component is 0 because it is parallel. Okay, so it is just over the top of this beam. So therefore, we will use only the component of the vertical component of P. So P times 2.5 B, P minus P multiplied by 2.5 minus B is equivalent to P sine 54.462 degrees multiplied by B. So to make the long story short, so we can cancel out the P And then, therefore, 2.5 minus b is equal to b sine 54.462. Okay, so by algebraic manipulation, we get b is equal to 1.378 meters. So the answer is b is 1.378 meters. So, therefore, this is the questions 2.22 and 2.24. So, this is the questions and the solutions. Okay. So, this is the example number 8 and number 9, respectively.